Hi everyone, just picking up where we left off on page 104 for the week 11 notes. So what we talked about in the last video was solving exponential equations. So if you remember, what it means to be an exponential equation is that it just looks like this right here. I'll just rewrite it over here. 7 to the x equals 500. It doesn't need to be those numbers, but to be an exponential equation means it has this. Exponential equation means there's an x up in the exponent. If you have an x in the exponent, you need to use one of the methods we learned in the last video to get it out of the exponent to make a solvable equation. So what we talked about last week was this first method of common bases. If you like common bases, it doesn't always work, but you can rewrite your bases, this one being 1 over 27, this one being 9, using the same base. For this one it was 3 and 3, and then your exponents just come down. It's a cool little common basis trick to help you get that x out of the exponent, and then you have a solvable equation. But like I said, that method doesn't always work. This method that we learned last always works no matter what, and you need to know it either way. Because if you do have one where common basis doesn't apply, even if you prefer that method, you still need to know how to use this log method. So let's go through another example of how to use logs, referring back to the last example we did in the first part of this video. So for 374, look at what we did as the first step. What's nice about the log method is there's really not much thinking. It's just remembering this process. You don't have to try and figure out what the common bases are. You just have to know. Your first step is to write the word log on both sides. That's it. So for this one, 375, my first step is going to be writing the word log in front of both sides. Nothing changes about the terms on each side, they just come down. You write the word log in front of them. Now that's what we did right here as our first step. Then notice the purpose of the log is to take that variable that's up in the exponent and chop it down to the front. So for this one, we're going to take that x minus 4 that's an exponent and bring it down in front. So x minus 4 will be written in front. Everything else just carries down. Log 5. That x minus 4 moved to the front, so you bring down your equals at this point, and then it's the log of 275. Now that you have a solvable equation, you want to get x by itself. The log has served its purpose. The whole reason for writing the word log on both sides was to make this step right here that we just did, bringing that x down in front, happen. Now that that's done, the log has served its purpose and we can get rid of it. So if your goal is to get this for now by itself, think of what's happening between this and the log of 5. They're being multiplied just like they were in the last example right here. So to get rid of that times log of 5, you're going to divide by the log of 5, and that cancels out. Over here, divide by the log of 5. So on the left side, you're just left with x minus 4, which is awesome. On the right side, you're going to have to plug that into your calculator. Now remember what we talked about in the last video. When you press the log button, it's going to give you an open parentheses. You're going to type in 275, and then you have to close your parentheses before you divide. So close those parentheses, then divide by the log of open parentheses 5, and then close those parentheses. So practice plugging that in your calculator if you didn't already. And this is the decimal that you should get. Remember, mine's going to be a little bit shorter. My calculator rounds early. As long as you have those first few digits, you are good to go. That's the whole log process. Once you're at this point, it's really just solving a standard linear equation where your goal is to get x by itself. X is not by itself, it has a minus 4 in the way. I have to add 4 to both sides to get rid of that. So when I add 4, I get 7.8, 489896. Oopsie. 489896. There we go. Okay, then round to the nearest tenth like it says in the directions. That's one place after the decimal point, but I have to refer to that digit after it. 5 or above, give it a shove. This is going to become 7.5. So watch that log process every time. You write the word log on both sides. You bring that exponent down, you divide by the log, and then you just solve like you would solve anything else. Same process every time. I'm going to add a tiny, tiny, tiny curveball into the mix before we do this next example. And it's this thing that's starred right at the bottom of your instructions here. It says you must get the term raised to the x alone before taking the log. So the last three examples, we started by writing the word log on both sides. That only worked because of its current setup, the way that it was given to you. So notice how this is set up. See how it's 7 raised to the x? There's no other numbers there. The term raised to the x was alone. So this one, same thing. 2 is raised to the x minus 3. This next one, 5, was raised to the x minus 4. There's only one base number there. There was a 7, then a 2, then a 5. Nothing else to it than that. If you look at this next example for 376, what's being raised to the x is just the 2. Remember, we talked about that when we did exponent rules in the first part of this video. What's being raised to the exponent is in parentheses, so only the 2 is being raised. So you can't use logs until you get that 2 to the x by itself. Right now it's being, oh man. Pause. There we go. Sorry guys, I do that a lot. Okay, right now, 50 is being multiplied by that 2 to the x. And if my goal is to get that 2 to the x by itself, I've got to move that times 50 to the other side. And I'm going to do so by dividing by 50. So that notice right here, these 50s completely cancel out. So I'm left with the 2 to the x that I needed to be alone on the left side. And then on the right side, I just do 1,000 divided by 50. And that gets me 20. So now this 2 to the x is by itself, and I'm good to start using logs. That's the only extra step you have to check for if there's a number in front of what's being raised to the x. Now, the reason that it's not just this, a lot of people try and just multiply the 50 and the 2 together to get this. That is a big no-no. The reason for that is PEMDAS, believe it or not. Exponents need to be taken care of before multiplication. That 2 has an exponent on it. So this is supposed to be done by following PEMDAS before you multiply. If you can't take care of that exponent, you can't move on to the next steps in PEMDAS. You're stuck. So that's why we have to divide by the 50 rather than just multiplying that out. It's all because of PEMDAS. Okay? So now I'm good to go. I'm good to try using logs. Pause the video for a second and try following that log method that we just used from the very beginning in the question right next to it. Write the word log on both sides, bring the exponent down, and then divide. I'm just going to jump right into it. Okay, so it becomes the log of 2 to the x equals the log of 20. The whole point in writing the word log was to take this x and bring it down. So now it's x log of 2 equals the log of 20. The log has served its purpose by bringing the x down, so I can get rid of it now. X is being multiplied by the log of 2, so I'm going to divide both sides by the log of 2. So these log 2's cancel, and I'm left with x equals, remember when you plug this in your calculator, make sure you close the parentheses that the calculator gives you. And you should get 4.321928. And again, yours might be a little bit different at the end or a little bit longer. Don't stress about that. When you round to the nearest tenth, which is this place right here, refer to that number. It is not 5 or above, so it doesn't bump that up. Your answer is going to be 4.3. All right, next one looks scarier because it has bigger numbers. It is the exact same setup as 376. If you feel comfortable with this, I want you to pause the video again and give this one a try. It's about as hard as the questions are going to get for you. If you don't feel comfortable with it, it's scaring you, Just follow along with the steps with me. So looking back at 376, I remember that I need to get the number that's being raised to the x by itself before I can use logs, which means I have to get rid of that 500. 500 is being multiplied to 1.02. So I need to get rid of it by doing the opposite and dividing both sides by 500. Remember, you can't just multiply these together because PEMDAS doesn't allow it. So 500 divided by 500 is going to cancel out, so you're left with 1.02 raised to the x over 12. Now I have that number by itself, which is perfect. And 2300 divided by 500 is 4.6, a nice decimal. Remember, if that is the long decimal, you have to write out the whole thing. You never, ever, ever round until your final step. You'll see that again in the next example. Okay, so now I need to write the word log on both sides. Now that I've got this by itself, I'm good to go. So it's the log of 1.02 to the x over 12 equals the log of 4.6. We're now going to take that exponent and bring it down in front because writing the log allows me to do so. So x over 12 is brought down to the front of the log of 1.02, and that's equal to the log of 4.6. Now the log served its purpose. It brought this exponent down in front for me. So now I'm done using it. I'm going to get rid of it. It's being multiplied, so I divide by the log of 1.02. Another thing some people tend to get caught up with is they divide by the log of 4.6. You don't want to do that. Your goal is to get x alone. Remember, that's always the goal. X is on this side, so you want to move this log over to the other side. Get everything away from the x so that these cancel out. I'm just going to scoot up here. You're left with x over 12 equals, when you divide this, I can't stress it enough, make sure you close the parentheses that it gives you. Pretty big number, 77.06332.5. Again, if you're not getting these numbers when you're plugging these logs into your calculator, you're going to have to email me or reach out during office hours. Okay, my last step to get that x by itself. Right now x is being divided by 12. So to undo that, I'm going to multiply both sides by 12. And like I said, you never round until the very, very, very last step. So that's why I had to write out this whole decimal. And that's why in your calculator, you're going to use that whole decimal times 12. Never round it to just 77. You're going to miss part of your answer. That decimal counts. When you multiply that by 12, you should get 924.7599. Again, your decimal will be longer. And when I round to the nearest tenth, I refer to this number after the 7, 5 or above. Give it a shove. It is a 5, so it does count as high enough to bring that up. So it's going to become 924.8. Okay, and in class, I actually would have skipped this next example because I'm never going to give you one with all of those fractions. If you're up for a challenge, you can look at my answer key if you want. It's posted on Blackboard. You should get an answer of 4.8. So again, if you're up for a challenge, go for it. If you're scared of fractions, don't stress about it. I'm never going to give you something like that, okay? All right, now applying this to some real life scenarios, we're going to go over a formula called growth and decay. So that's this formula right here at the top. Everything within this box does not need to be memorized. This box will be given whenever needed on a test or a quiz, just like the rest of your formulas. But this one's extra special because I'm giving you all of this too. So you are going to you're going to be given the formula, which we'll talk about in a minute, and you're going to be given what each of the variables stands for. So A stands for your final amount, P stands for your initial amount, which is also known as your starting amount. Your rate is your percentage, but it must be written as a decimal. So for example, if you have 5%, you're not going to plug in 5, you're going to plug in 0.05. Remember when we did that a while back? You just take that 5% and divide it by 100, and that'll get you the decimal version. And then t is time. Okay, the only other thing you need to know from this formula is the difference between plus and minus. You're actually not going to refer to that plus or minus the way that we did with the quadratic formula. The plus in this formula means growth, and the minus in this formula means decay. So it's going to be all about the wording in the problem. If you have something increasing or growing, you're going to only use the plus. If you have something getting smaller or decaying or decreasing, any of those words that mean getting smaller, you're going to use the minus sign only. That's practice makes perfect. Here we go. 379 says, if the population of buffalo is decreasing by 4% per year and started with 258,612 residents, what is the projected population in 5 years? So the fact that it's decreasing by a percentage is the hint that tells you you're going to use this formula. So the first thing I'm going to do is write the formula, and I'm going to write it using this clue. The population is decreasing, which means I'm going to use subtraction from my formula. So A equals P times 1 minus R raised to the T. Now before I go plugging in, I'm going to organize my life off to the side here. I have A that I need, P, R, and T. I need a party. We're partying off to the side. A party. A is your ending or final amount. The question in this problem was, what is the projected population in 5 years? It's asking you what that ending amount is going to be at the end of 5 years. So A is the variable that I don't know in this problem. P is the starting amount. It says right here that the population started with this many residents. So my P is going to be 258,612. R, it says in the directions, represents your rate. Your rate is 4%, but remember we don't plug it in as a percent. We're going to do 4 divided by 100, which is actually 0.04. So R is going to be 0.04. And T is time. Time is right here at the very end, 5 years. Boom, 5. So now we just plug in. Everywhere we see the variable we have a number for, we plug that number in there. So A is left alone. P, it's pretty big. Be careful copying it over. 258,612 times, or parentheses, 1 minus from the formula. R is 0.04, and I raised that to the T, so raised to the 5th power. So take your calculator and type this in exactly how you see it. You don't have to do it piece by piece, just plug it in exactly how you see it, parentheses and all, and you should get this. Again, your decimal might be a little bit longer. I'm going to stop saying that, so you guys just hopefully know at this point your decimal will be longer than mine. So practice plugging that in. Make sense of your answer for all of these. It's growth or decay. The fact that the direction said decreasing means my final amount should be less than my starting amount, and it is. So this makes sense. If I ended up with a negative number, does that make sense? No. That'd be a big sign to me that tells me I've done something wrong. So just make sense of your answer when you have word problems. It'll definitely help you long run. And it does say at the top to round to the nearest whole number, but try and think about what we're working with here. We're working with people. You want it to be the nearest whole number anyway. So it's going to be 210,000, that is an ugly comma, 210,865 residents. That's your final answer. The reason that 5 did not bump up is because if you're rounding to the nearest whole number, this is where you want your number to end, right before the decimal. You still need to look at the digit after the decimal point to see if it'll bump that up, but 1 does not bump the 5 up, so it stays. All right, let's do that same process all over again with the next one. If $560 is invested in a bank account that earns 4.3% interest per year, determine the amount in that account at the end of 10 years. So this one is earning money. If you're earning money, it's increasing, so your formula is going to be slightly different in that instead of a minus, you're going to use a plus. Okay, simply from the word earns, I knew I had to use plus. Now off to the side, I'm going to write a party, A-P-R-T, and then organize the numbers in the problem. So $560 was invested in the bank account. That's what it's starting at. So 560 is going to be P. It's again asking you to determine the amount in the account at the end of a certain amount of time. So that means you're not sure what the ending amount is. I'm going to leave A as a question mark. R is the rate that it's increasing by. In this one, it's 4.3%. But remember, you don't plug in percent. You have to change that to a decimal. Do it in your calculator if you need to. 4.3 is a percent, so it's out of 100. You'll get 0.043 as your decimal. And then T is your time, which in this one is 10 years. So I now plug it all in. A stays. P is 560 times 1 plus R is 0.043, and T is 10. And remember, you plug it all in at once. So practice plugging it in your calculator. I'm just going to write the answer down for you to check once you're done. Okay, pause it if you need some more time. I'm just going to keep going on. To round this to the nearest whole number, remember that ends right before the decimal point. You still need to look at this digit. That 1 will not bump that 3 up, so this is going to be $853, which makes sense because I started with 560. It was earning interest over a certain amount of time, and it ended up increasing towards the end. All right, I'm going to bring you back up to the top of this page real quick. Something that I skipped over because it didn't apply right away is something about the units that you're working with. So notice in the first example, you have a rate per year, and then it gave you the time in years. This next one, same thing, rate per year, and it gave you the time in years. R and T, add this to your notes if you will. R and T must be given in the same units for this formula to work. You can't have a rate per year and then plug in like 65 days. It's not going to work. They have to coincide with each other to be the same units. So you'll see that in 381. It says if a substance is decaying at a rate of 11% per hour, how much of a 160 kilogram sample remains after 1 day? So here's the problem here. My rate is per hour. My time is 1 day. You can't really change the rate percentage that's happening per hour. You want to leave that 11% alone. This is what we want to convert, and we want to convert it to match this. So we want to convert that 1 day to match the rate per hour. How many hours are in 1 day? 24 hours. So it's really one little extra step, but you're going to be plugging in 24 instead of 1 because you need your units to match. All right, what we're going to do now is write out the formula. This one says decaying. It even says decay right in the problem. So I'm going to use my decay formula. A equals P times 1 minus R to the T. And I'm going to have the party off to the side. A, P, R, T. It's again asking me how much of this remains after a certain amount of time. That means I don't know my ending amount. A is a question mark. We don't know it. P is what you start with, which in this case is 160. R is your rate. It is 11%, but we need to convert that to a decimal. When you divide it by 100 or scoot that decimal point 2 places to the left, you get 0.11. And And your t, remember, needs to be 24. For 1 day, you need to plug in 24 hours because the rate was changing per hour. All right, pause the video, take a second to plug this all in on your own, plug it in your calculator all on your own to see if you've got this. You should have gotten 10 as your answer. Hopefully you're coming back with 10 as your answer. If not, follow along with me just to make sure we've done it right. So P needs to be plugged in as 160. 1 minus R is 0.11. And then, oops, raised to the 24. Plug that all into your calculator. 96068. 151 is what you should have gotten when you plugged it in your calculator. And then when rounding, you want to stop here at the whole number right before the decimal point. But this 9 after the decimal point has enough power to bump that 9 up to a 10. So your final answer is going to be 10 kilograms. And again, that makes sense. We started with 160, it decayed, and it ended up at 10, which is smaller. Okay, this next example's going to be a little bit different, and you'll see why in just a second, but we're going to start it the same way. So a population of 70 fruit flies is increasing at a rate of 8.3% per day. There's my keyword that tells me this is going to be plus in my formula. Determine the number of days it will take for the fruit fly population to double. So it says increasing. I'm going to write out my formula to start. A equals P times 1 plus R to the T. And I'm going to have a party off to the side. I know my joke's getting tired, but I love it. A party. Okay, a population of 70 fruit flies is increasing. So it's telling me I'm starting with 70 fruit flies in the beginning, and it's going to increase now at a rate of 8.3%. When I divide that by 100, I get 0.083. So my R is 0.083. Then it doesn't give me any other numbers. But read what it says. Determine the number of days it will take for the fruit fly population to double. This right here, determine the number of days, is telling you you're not solving for A this time. You're trying to figure out your time. So we need to figure out what T is. And do note that days, oops, I didn't mean to cross it out. Days right here and days right here, your units match, so we're good to go. It's asking me to figure out what T is, or the number of days, so I'm going to leave T as the variable, which means I have to plug in an A. To find one of these variables, you have to plug in for the other 3. It's the only way it's going to work out. So I read the rest of this. Figure out the number of days it will take for the fruit fly population to double. So your ending amount, or A, is going to be double what you started with. So what you're going to do to figure out what A needs to be is double your starting amount by multiplying it by 2. That'll get you an A value of 140. All right, here we go with plugging these into the formula. So instead of leaving A, I'm going to plug in 140 in place of A and bring down the equals. Then I'm going to bring down P, which is 70, parentheses, 1 plus R, which is 0.083, and that's raised to the T. I'm going to leave that T there. Here's why this one's a little bit different in the way I need to solve it as well. Look at where your variable is. Your variable is up in the exponent. This is an exponential equation, which means you need to use logs to solve it. You knew it was going to come back. You could try to use common bases, but you're trying to use this as your common base, 1.083. And that's not going to turn into a nice common base. So this is definitely one of those scenarios where you need to use logs. Now, before you get all crazy and you love logs so much and you just start writing the word log on both sides, remember, you're not allowed to take the log of both sides until what's being raised to this variable is by itself. 1 plus 0.083 is inside of the parentheses. So that's all that's being raised to the t. The 70 needs to move to the other side before I can take the log of both sides. You're used to seeing the sides of this equation flip-flopped. If you want to flip-flop them, go for it. But because you're going to need to see it in this setup, I'm just going to continue on like this. So again, I'm trying to get this in the box by itself, so I'm going to undo that times 70 by dividing both sides by 70. So that this cancels out. 140 divided by 70 is just 2, which is very nice. And I'm going to simplify this because it's a very easy thing to simplify. 1 plus 0.083 is just 1.083 to the t. Now, I got that number that's being raised to the t by itself, so I'm ready to use logs. So remember that log process. Your first step is to write the word log on both sides. So the log of 2 is equal to the log of 1.083 to the t. Now the whole point in writing the word log is to take this variable and chop it down and bring it to the front. Here's why I wanted to leave it on this side. You don't bring it all the way to the front. You bring it in front of what it's attached to. So the log of 2 stays here. The t comes down in front of the what it's attached to. And then that log of 1.083 comes down. Now, what we did was we took the log of both sides. We brought the variable down in front because I took the log of both sides. Now the log did what it was supposed to do, I can get rid of it. Your goal is to solve for t. So you want t by itself. If you want t alone, that means you've got to get rid of this right here. I'm going to get rid of that by doing the opposite and dividing by it. So divide by the log of 1.083. Divide by the log of 1.083 so that this will cancel out. You'll be left with a t by itself, even though it's on the right side, that's okay. And then plug in the log of 2, make sure you close those parentheses, divided by the log of 1.083, make sure you close those as well. Here's the decimal you should get. Okay, 8.693139. Again, your decimal might be a little bit longer, but that's what you should get when you plug this in. Now, I need to round to the nearest whole number, which means I'm going to end here right before the decimal point, but I need to look at this digit after the decimal point. It is a 5 or above, so it bumps that up to about 9 days. So that tells me it would take this fruit fly population 9 days to double. All right, only a couple more examples on the next page. Before we jump into those, I'm going to give you the code word. Okay, the code word for today is sunny. Okay, code word for today is sunny. Hopefully we're getting some nice sunny days. All right, so 2 more problems. It might help you because you're on a different page to just copy this down real quick. It's just the growth and decay formula. Again, that will always be given to you, but just so you don't have to keep flipping back and forth. There it is. So remember, you know that you need to use this formula when you are growing, increasing, decreasing, whatever, by a percent. That's what tells you this formula comes into play. That's something you still need to know. Even though I provide you with the formula, you need to know when it works. All right, so for 383, the population of a nearby town is growing at a rate of 2.9% per year. I'm just going to box that word growing because it tells me to use the plus. I'm just going to write it. A is equal to P times 1 plus R to the T. If its current population is 12,000, how many years will it take for the population to exceed 36,000? So this word exceed is really important, but we're going to deal with it later on in the problem. Okay? So don't worry about it for now. We will come back to it. So we have a party off to the side. No, my joke is not getting tired. You love it. Okay, and I'm just going to read through and pick out all the important information and put it where it's supposed to go. So it's growing at a rate of 2.9%. That means R is 2.9%, but I convert it to a decimal and get 0.029. Its current population is 12,000. That means P is going to be 12,000. And again, it's asking me how many years. So how many years means I need to figure out what T is. So how many years will it take for the population to exceed 36,000? Again, we're going to not worry about that word exceed for a second. I just want you to plug in 36,000. We'll talk about it in a little bit. So by plugging in 36,000, we're going to find out how long it takes to reach 36,000. So if you feel comfortable, take a second to plug everything in. 36,000 equals 12,000. Hopefully you end up with exactly what we have on the screen right now. Okay. Again, my variable is in the exponent, which tells me I need logs. You can't use logs until the number being raised to that t is by itself. So your first step is to get rid of the 12,000, and you do so by dividing because they're being multiplied. So divide both sides by 12,000. So these cancel out. 36,000 divided by 12,000 is 3, which again is a nice situation. I'm going to do what I did in the last one and just add these together because it's very simple to add those. It's just 1.029, and my t in the exponent comes down. Now that we're all set up, pause it for a second and try and use that log method going forward here. So you start by writing the word log on both sides. The whole point in taking the log of both sides was so that that variable can come down in front. Remember, it goes in front of what it's attached to. So the log of 3 stays and just comes down. Then it becomes t times the log of 1.029. Now the log served its purpose because it brought that variable down, so I'm good to go and get rid of it. And I'm going to do so by trying to get t by itself. T is being multiplied by the log of 1.029, so I would divide by the log of 1.029. So these cancel, and you're just left with t, which is awesome. On the left side, you're going to plug that in your calculator, log of 3, close your parentheses, divided by the log of 1.029, and I'm going to write down what you should have gotten. If you're not getting these, remember you need to reach out to me. If it's a matter of plugging in your calculator that's not going right, I've got to see what's going on to help you guys out. So for the nearest whole number, nope, not quite. I almost forgot myself. So this is the decimal that you should have gotten. If you were to round this to the nearest whole number, it would stay 38. But I want you to think about what we were trying to find. Remember this right here, exceed. So this is our answer. What that answer means is it takes 38.4298 blah, blah, blah years to reach 36,000. At 38 years, it hasn't quite reached 36,000 yet. This problem told me it takes exactly 38.429 blah, blah, blah years to reach 36,000. So if I'm trying to exceed 36,000, it's going to take a full 39 years when I'm rounding to the nearest whole number to exceed. Oh man, I did it again. So your answer, is 39 years. And I'll explain that again. So if I rounded this to the nearest whole number like we've been doing all along, that 4 would not bump the 8 up and it would be 38 years. But your answer tells you that it takes 38.4 years, almost 38 and a half years, to reach 36,000. The problem's specific word here is to exceed 36,000. So if it takes about 38 and a half years just to reach it, it's going to take a full 39 years to exceed it when we round to the nearest whole number. 38 is just not going to cut it. It won't reach 36,000 yet at that point. All right, one more problem. I'd actually love if you guys paused your video and tried to do this one completely on your own. I'm going to jump right into it. So please pause it, give it a try on your own. Here we go. So a substance of originally 50 pounds is decaying at a rate of 2% each year. How long will it take until only half of the substance is left? So the first thing I noticed was the word decaying. That tells me I'm going to use my minus, or my decay formula. Don't forget your party off to the side. It says a substance of originally 50, so that means P is 50. That's what we're starting with. It's decaying at 2% each year, which is actually 0.02. How long will it take? So I'm trying to find T again, until only half of the substance is left. So my final amount is half of the substance. So half of what I started with, so aka half of 50, tells me that A is going to be 25. All right, now that I have all of my numbers, I'm going to plug it in. A is half of 25, half of 50, which got us 25. P was 50 times 1 minus that R value of 0.02, and that's raised to the who knows. I'm going to solve this the same way I solved the last couple of examples. Because I'm trying to find the variable and the exponent, I need to use logs. But, I can't write log on both sides or start using that log method until what's being raised to the t is by itself. So the first thing I need to do is get rid of that 50, which is being multiplied to that whole thing I need by itself. So to undo that, I'm going to divide both sides by 50. Now be careful on the left side. 25 divided by 50 is 0.5, or 1/2 if you want to leave it as a fraction. Be careful over here as well. Before we were just adding 1 plus 0.02, or whatever the numbers were, and we got 1.02. This one's subtraction. 1 minus 0.02, you can throw it in your calculator. That'll get you 0.98. And then the raised to the t comes down. So again, I divided this to get the 0.5, and I subtracted this here to get the 0.98. Now I got the number being raised to the t by itself, so I'm good to use logs. The log of 0.5 is equal to the log of 0.98 to the t. The whole point of the log is to take that t and bring it down. See how it's the same process every time? It's actually really nice. So that t comes down in front of what it's attached to, looking like this. And then my last step here, now that the log served its purpose, is to get rid of it. My goal is to get t by itself. T is being multiplied by that log that I'm getting rid of, so I'm going to divide by it. So I'm dividing both sides by the log of 0.98. So this will cancel out and leave me with t. In the calculator, remember, close your parentheses where you need to. Log of 0.5, close your parentheses, divided by the log of 0.98, close your parentheses, and here's the decimal that you should get. Okay, hopefully we got that. Again, if you haven't and you've been having issues, please reach out to me through email or come to my office hours on Tuesdays and or Thursdays. When I round this to the nearest whole number, that means I want it to end here right before the decimal point. So I look at this number after it. 3 will not bump that up, so it's going to be about 34 years. Okay, so get practicing on the homework for this. Make sure you really understand how to use logs and how to solve